So I'm going to start by not repeating myself in terms of the recap I did on cycle main procedures and linear main procedures, because in fact that conversation did reach its end. So I now want to move on to the planned thing, which was actually stitching it all together. To me, we've gone over the past many weeks, we've talked about all sorts of little bits and pieces that can be used to make the database self-aware, agile, self-validating, and all those wonderful things we want out of the database. And I'm pretty certain that a lot of you are sitting there saying, yes, but how do I put all the pieces together? How does it work for me? And how do I understand what I need to do? And that's what I want to do today. I want to take a little program. Now I'm going to switch over to my, no, it's not that one. I'll find it eventually. It was this one here. I have on my, in my little advanced modernization workshop library, I have, and I tend to do this all the time, I tend to create a little test program per file. Now, I think I went through a bit of this last time, but I'm going to repeat myself so I can start from the beginning. I generally create this little test file to help me to check that I've got all the pieces of the database working together, that I haven't left anything out, that I've got all the constraints and triggers attached, and everything is actually as it should be. This one, in fact, is using a linear main procedure, and the code is exceptionally simple. I have got the I/O server for the master file. I'm doing this on the customer master file, and I will just haul this across to show you that the customer master file is defined. It has a unique key customer number. I'll make it a little bigger maybe to help. It also has a referential constraint to the rep code file, connected by rep code, to make sure that you can't put a rep code onto this master file if they're not defined in the rep master file. It has 3 before triggers, a before delete, a before insert, a before update trigger. It has 1 after trigger, and a number of logical files. But it's importantly I'm going to hide the logicals. Importantly, it's the constraints and the triggers, as well as the I/O server, that are the various components around this file that we want to stitch together and show you exactly how it all works. And this is very, very important, because the number of people who have come to me and said, I just don't know how these things fit together. Things are happening and I don't know where they're happening. I don't know why they're happening, and I don't know what to do about it. So the purpose of this whole exercise is to try and give you the route to follow. So we have the I/O server defined. It's got there's its prototype with its 3 parameters, which we will see in action just now. I then have my error handler, which is the percolation handler, which is going to, if there's an error, it's going to percolate it up to the caller. So I'm going to start this by actually placing a debug service entry into RDI. You will see it goes in here at the bottom in the IBMI service entry points. It is entered there as an entry point. Now, please, as I'm going through this, if there's anybody not certain, wants to ask a question, please do so at the point. Interrupt me so that we can look at it at the point at which I am. Otherwise, I'm going to have to go back and start all over again. So if you have a question about why something is looking the way it is, please interrupt me straight away. All right, so I've added the breakpoint or the service entry point into RDI. Now all I'm going to do is I'm going to call this little test program of mine. I have a command line here, and I'm going to call CUSTEST, cust test. Now last time it didn't work. Let's see. No, it didn't work again. Curses. All right, forgive me. I'm going to have to just shut this down. Got to get the debug working. Sorry, I'm just getting the ducks in a row. Okay, that's fine. So I'm going to go back to the source file, and I'm going to again set that service entry point, because closing down the RDI has cancelled the service entry point. So hopefully, there we are. Just as a matter of interest, we've been informed here in South Africa that the SECOM cable, which runs up the east coast of Africa, which is mainly used for my communications with Europe and the United States, is being broken. Somebody dragged a fishing net through it or something. So they have rerouted a lot of the communications, but there might be some whiteouts or timeouts or delays in the comms because of it. Hopefully not too serious. Okay, now I'm going to find my call again here, and I'm going to press enter. Right, this. Oh, I'm getting very annoyed. It's probably because, sorry, forgive me, this is a little fussy, and I just want to make sure. It's probably to do with my library list. I just want to put this in order. I'm setting up a test environment library list, and I also just want to add the AMWDB library to that library list, so we'll check that. It might not have picked up. It's amazing, you know, I actually went through this whole exercise just before I started up the session. And, there we are. Right. No, I'm sorry. Please forgive me. I do not understand what is happening at the moment. CUS test AMWDB. It will not call in the breakpoint. This is most annoying. Oh dear. The debug, which was working quite successfully. Sorry, I'm just going to terminate this lot and try again. Terminate this. Shut that down. After all the possible excitement of this, it's actually a nuisance. But I'll get there, don't worry. If you'll just bear with me a little bit. Okay. Right, all I can do is try again, people, and hopefully this time RPI will actually listen to me. Setting the service entry point is as it should be. Setting the library list. The thing with this is that when you actually do this type of thing, you need your library list to be absolutely correct, because remember that there are calls taking place from the database management system that need the library list in order to get hold of the right version of the program. If you haven't got the library list absolutely correct, then you could end up calling the wrong trigger or the wrong I/O server, and you could, of course, end up in a little bit of a shambles. That looks all right. So hopefully I have the service entry point enabled, and I can now hopefully know what on earth is going on. I'm very sorry about this. I do not understand why it is I'm not getting something working that is actually was perfectly acceptable and worked 100% 20 minutes ago. I have not had this happen to me before, and I don't quite know why it is doing it. Oh, I can't possibly need to reboot my machine because of... I could, but Dimitri, I don't particularly want to. the library list on the job I'm invoking is this one here, which actually has got AMWDB as the current one, and then the test environment, which is all I really need. And if I use the green screen interactive debug, it's not quite as demonstrative of what I want to do, but if I'm forced to, I'm going to have to do that. I just do not really understand. I mean, I probably do this sort of thing 300 times a day. And only when I want to show it to you people and get all excited about it, does it give me this type of hassle. Yeah, but that's why I've rebooted a couple of times, and I haven't got any strange messages lying behind this thing. Nope. It's actually invoking the debug, but as you can see, it's actually invoking the debug, but it's not entering a breakpoint, which is quite annoying. So let's see whether I can put in a breakpoint. Nope. What is going to happen, Marinus, if I actually reboot my system? The Webex will be lost. I'll have to open up a new session. Is that what will happen? All right, I'm going to try that because I can't think of anything else to do because I cannot get this. I've shut down the Webex session. Let me shut down the green screen sessions. Right. Yeah, that's going to be a very good question. How the hell am I going to do this? Because if I shut down and reboot, it's going to become terribly messy because the session is... all right, let's hopefully see if I can now... reloading the workbench. Library lists. Trying it again, people. I'm very sorry for this. It's most annoying, particularly as I was very careful to do the whole exercise 15 minutes before the session to make sure that it didn't do this. Library to test. That's fine. Now we go down. I'm getting a flash of something on the screen that I don't like. And I don't think this is going to work. Let me try, but I don't somehow think it's going to work. All right, I have created hooray. I've got it to work. You tell me why it wouldn't, and now it has. As you can see, I have typed in call cust test, and I've got a system active. I will come back to that just now. And I have now got my debug, and it's taken me into the cust test program, and it's taken me to the main line. The blue arrow indicates where I am. Maybe a comms glitch, I don't know. Anyway, we're there. Let's hope it'll last through the whole exercise. Right. The test program is written to test out all aspects of this particular file and its behavior. So if we step down, this here, if you look at the top, you will see that the default activation group is no, and the activation group that this program is going to be running in is a system-created activation group, i.e. *new. As a result, this is a brand new activation group, and the consequence of that is that I have to start the commitment control for this activation group. Understand commitment control in the new paradigm of modern coding is absolutely essential, and you're going to see why in a minute. And so starting commitment control for the beginning of an activation group is critically important. If you don't do this, then what happens is this activation group's commit cycle falls under the caller's activation group, and you get an overlap of commit cycles, which can produce unexpected results. So it's very important to make sure you start commitment control for each new activation group. Unless, of course, you deliberately want to overlap it, in which case you don't. Right. Customer number is generated by the I/O server. That was the plan, that was the design. Therefore, I don't have to populate it. Start date was to be populated by the trigger. On insert, therefore, I don't have to populate it. User ID, similarly. User ID to be put in by the trigger, don't populate it, and the record status is not used for this file. It's blank, and it's forced to blank in the trigger. As a result, the only fields I need to put anything into are the customer's name, a phone number, and the rep code, which, as I said yesterday, I think this is where I got to last session. Rep code 44 is invalid. It does not exist on the rep master file. The rep master file only contains one record, and it is It is 22. This is the rep master file, and it is 22. As a result, that 44 that I have here is actually invalid and will based on the fact that there's a constraint on this file to the rep master file, it will in fact cause a referential integrity error. Now the question is, when will it create the referential integrity error? So let's move on one step, and we populate the customer name. Now what I'm going to do here is I have the record layout monitored by the debug, and we can see as I step through this, information is added to the record layout, and I come to the input out to the IO server for the master file. Now, I says insert this record, and the pointer is this pointer up here, which actually is the address of the customer record, which you are seeing on the left-hand side here. So that customer record is now going to be passed through to the IO server using the pointer that has been set as the address of that record. I could just as easily use the record name and pass that through, but I would have to write my IO server slightly differently, and then certain functionality would be limited, because it then only would consist of a single record, and I would not have the option of making it a multiple record IO. So let me step into the IO server, because if you're looking at this test program, you're seeing I've populated 3 fields, and I'm going to say insert it. That's all this program does. No validations, no checking, nothing. This can come from a very simple interface. And I'm just saying, take this information, insert it, let's see what happens now. So I'm going to step into the IO server. If, of course, the mechanics allow me to. There is the main line of the IO server. The IO server is a procedure inside a service program. It has an FSpec for the customer master file, because it's designed to provide IO services for the customer master file. And there is its parameter interface, its prototype with the 3 parameters. We step forward, and it will take us straight into the beginning of the procedure that actually is the IO server itself. Now, I want you to take note carefully what happens here. I'll step in, now I'm into a monitor group. The monitor's there, the on error's there. So anything that goes wrong between these 2 statements will be reported in an on error condition there. But watch what happens now. I say, if the file is not open, I'm stressing this so that you can see what happens just now when I do this again. If the file is not open, I then open it. So stepping forward, you will see that test says the file is not open. Therefore, I'm going to open the master file. Action, I move the A across to action to split it up into its 2 1-byte pieces. And then I move the P, which is the pointer that was passed through here. I move that to the customer master file pointer, which is there. And at the moment has a null. But if I step 1 line down and then go back to that pointer, you will see it now has a value. And the record there is based on that pointer. So the contents of this record, I'm going to put them into the expression again. You will see they are identical to what they were in the test program. Okay, so I'm in my IO server. I have taken the pointer. I've placed it in the, and so I have technically read the buffer. And now the IO server can operate on that buffer. Everybody happy so far? No questions? The first thing I do is I select, when there are two parameters and A1 is a D, that means I'm trying to delete something. When parameters are 3, it means I've passed through a key. Now, if I go back, you will see I actually only use parameter 1 and 2. I'm not passing through a key because I'm doing an insert. And that insert assumes that the key will be in the record. So I'm going to do an insert, assuming that the key is part of the record, i.e. I will step past that one, and I will step past that one, and I will come to here. So I have not put the key into the key structure, and I haven't done this either. But I know that I actually have an invalid key in this record. There it is there. It's invalid. Well, it's not invalid, but it's a lot of nonsense. So let's see what this IO server does to correct that issue, which normally would have to be done in the application code. I'm going to step, and because I know that it's an insert, I'm now going to call the put routine, which is a function which returns a Boolean indicator. So I'm going to step into that, and here we are. The first thing I'm going to do is I'm going to set the set lower limits to high val for the customer master file. Because the first thing that I want to do before I write this record is I want to find the next customer number. Now I've got this, I do it this way all the time. I've got absolute control. It happens very fast. It eliminates the potential for any gaps in the numbering sequence, and the rollback will free up that number again if it's necessary to roll it back. Other methods tend to either get duplicates or leave gaps which have to be programmed out. I set lower limits on high val. I read previous no lock customer master file, and I place it into the save record. And there's a reason for that. Is because the save record is like the record, which is that record there. But this record contains my new record. And therefore, reading for update, which I can find here, or reading to get the last record in the file, I cannot put that record into the actual record buffer, so I put it into a save record. The save record, let's read it. The save record has a record in it. It's customer number 1, and it has all its details in it quite correctly. So I've read the last record on the file. If I hit end of file, which I will only ever hit once, I make the customer number a 1. Else, I make the customer number equal to the previous record that I just read plus 1. And that is how I manage to assign the next number in the sequence. It's absolute control, and at the moment, the customer number 2 is now reserved. You can see here on this left-hand side here, there's a red line there, which means I've updated that record to a 2. Notice both these records are showing a 2, even though they were monitored from before I came to I monitored the one here in the test program. I monitored the other one here in the IO server. But actually, because they're based on the same pointer, they are the same record, and they will show up here in the debug as the same record. Okay, so I have generated my customer number. Now, the importance of this is that the record here, this record here, which is this record here in the calling program, has now got the number 2 in it. So this number is available to the calling program after the insert. So the calling program can now use that to go and do other things or inform people that customer number 2 has been added to the file or whatever. Other methods don't necessarily make that number available on insert. And that is one of the big reasons for doing this. Okay, so I have now created the customer number. Now, at this particular point in time, the start date is blank. And date in a date format that is blank is invalid. If I attempt to write that record, the operating system first does an integrity check on the data that is in that record, and it will give me an error because the format of the date field is invalid, which is why, which is why I add the start date here in the IO server in order to get the date field into the correct format before I issue the write. That unfortunately is a kink in the database or in the data IO, or maybe it's not a kink, maybe it's a deliberate integrity check to make sure that numbers have numbers and dates have dates and so on and so forth before the write actually happens. It will happen and it will throw it out at the beginning of the write. Now, here's where the fun comes in. So far, I guess it's fairly straightforward. You can see the start date has gone red in both cases. It's been given today's date. Now, this write is a request to the database management system to actually take the record, rec, which, if I go back up here, is in fact that record there defined for that file, which is that record. I've renamed it just for the fact that then I don't have to type it quite so often. And it says, I want you now, Mr. Database Management System, to write this record. So what I'm going to do is I'm going to step into this from the debug. I'm going to step into the write. You cannot debug the operating system, but you can step into anything that the operating system calls, which of course is going to be the trigger. So I'm going to step into that. And there we see the trigger has been brought up in the constraint, or in the call stack. You can see the trigger program is now sitting at the top. And I now have, I can step into the actual procedure that makes up. This trigger program has been written as a linear mainline. There it is there. Its activation group is no default, and I'm using star caller. And I now am into the actual program that is the trigger. So now this code is also invisible. I started here with an insert. The actual IO server took me through some processes and gave me a customer number and a date and wrote the record. And now I'm in the before trigger that is now going to validate that record. before anything else happens. So you can see there's a lot of code that is being utilized that is not visible up front. And for those people who are not familiar with this method or these invisible connections, it's going to be very confusing. And this is why this needs practice. And this debug methodology of testing it is the best way that I have ever found of getting comfortable and familiar with how the calls take place. Okay, so let's step. The first thing we do is we take the address of P, which is the address of the parameter list, and we put it into a thing called PP, which is the parameter pointer, which is the pointer, the address of the beginning of the parameter list, which is there, which is like the data structure P1, which is up there. So there is our parameter list addressed by PP, which is the address of that parameter list. Step down one, and we come to the event. The event is a 1, which is indicating that this is the result of an insert request. So I will then take the parameter pointer and add to it the offset to the new record, creating a pointer called NP. Now I'm going to play this one. I'm going to delete these monitors here, and I'm going to go up here, and I'm going to pick this, and I'm going to put this in as a monitor expression. Now, when you see this, when you're monitoring in a debug, what it means is that I don't know what you're talking about. I've got an N, it's a structure, but it's based on nothing. I haven't got a value for the based on pointer, and therefore I can't tell you what's there because I don't know where it is. That's essentially what these asterisks mean. So when I get to here, I'm going to now take the parameter pointer, and I'm going to add that to the offset, which is 192, and I'm going to come up with NP, which is the new record pointer, currently null, on which this record N is based. So let's just step that and see what happens to this record here straight away. N has now become all red. It was changed, and it has now become a known record, which is part of the parameter list of the trigger. You can see the number 2 is sitting there because that was put in by the IO server before the write took place. So the 2 is there, and now we enter into the default routine. Default routine. The default routine is to make the record status a blank. As it was already a blank, it doesn't show red. It also is determined to make the user ID into my username, and as it's changed it, it shows up red there as well. So you can see that the defaults are correct. Now you're looking at all of this. This record looks correct. So by doing this type of debugging, you can check every step of the way. You can hover over anything, see that it has the right value, and so on and so forth. Notice it missed this percolation and dropped to the end monitor, didn't find any errors. So we go back, and we end up at the insert event, which we now need to execute. So we go to the insert event, and this insert event is also carrying the same statement. Why? Because this is a business rule for inserts, and I like to encapsulate all the business rules for a particular file in the before trigger. The fact that I'm duplicating it, some people would argue that it's a waste of time. I won't deny that. You can leave it where it is or take it out, but I tend to encapsulate the rules. So I look in one place for the rules. No problem, it didn't change anything. Insert event is complete. I go to the validate routine. Here, the validate routine will check to see is the customer number a 0. It's not, so I don't indicate an error. And is the customer number a blank? It's not, so I don't indicate an error. So I've gone through a validate routine. Now, big files could have very long validate routines. They could be long. But that's what it's all about. You want to encapsulate and build all the validations for every field in a file into one trigger, so that you've got one place to change, you've got one place to look. I just want to stress something here. When you attach a trigger definition to a file, you have to have an exclusive lock on that file. That's for the definition. You can subsequently make changes to the trigger program, recompile the trigger program without having to have an exclusive lock on the file. This is something that sometimes people seem to misunderstand. It's a case of when you add the trigger definition to the file, you need a lock. But once you've done that, it behaves exactly the same way as any other program which you change while in use. If the trigger's in use, it will continue to use the cached original version until that program is terminated. And when the program is terminated, the next time it's opened, it will use the new version of the program, and you do not need a lock to make that change. I'm just stressing that because that does tend to cause confusion. Right, so having got to the end of the validate routine, again, I found no errors in that monitor group that weren't expected, so I didn't hit the percolate. I go back to the main line, which is here. And of course, I have basically finished with the main line because the event was an insert. So my next step will be down to the if error condition. Now we know from what I said earlier, there is still an error here. The actual rep code is incorrect. It's invalid. But I haven't tested for it because I know that it is managed by a referential constraint. So let's see. If error. The error indicator is not on. It was turned off, just as a matter of interest, at the beginning of the validate routine. There's your reset error. And it hasn't been turned on by the validate routine. So there are no errors that this trigger has actually found. So we will step over that. And of course, we never ended up at this on error condition, so there are no unexpected errors that were found between the monitor and the on error. So we'll step over that as well. So what we've got here is we've got to the return of the before trigger without actually having an error, which we expected to have. Everything has been checked in the before trigger. Just hang on a sec. Thanks, I had a fan on and it was getting a little chilly. So the before trigger has done its job. And this is fairly small. There are a few fields that need checking. It's not a lot of code, but it has been executed under the covers without the developers actually knowing that it's happening, unless they are trained to look for triggers and to understand how they fit into the grand scheme of things. I'm going to return, but I'm going to return with a step into and another one. And now, immediately, we get a call to the after trigger. Remember, we're in a commitment control group, a commit cycle. And I want to show you what has happened here. Let me bring this in. I think I've got SQL. Yes, I have. Customer master file. We have come through the before trigger with the customer master file. And if I look at it now, I have 2 records in the file that I can see. The second one has got a lock on it. If you try and do anything with that, you're going to end up with a locked record. But you can see it. There's record 2, and it's sitting in the file because the before trigger is now complete and the record is placed into the file because the before trigger has not found anything wrong with it. Now we enter the after trigger, as you can see. First step in the after trigger takes me to the beginning of the main line. Again, this is a linear main program. Sorry, I've got a question here. Let me... I'm just reading a question from Marinus here. Okay. Yeah, all right, I'll pick that up. We can talk about that. Marinus is just suggesting that I actually emphasize the data centricity of what we're doing here. The fact that this is all done by the database. The original program asked for an insert. All of what is happening now is done within the database. It's very database centric. And the actual application code that asked for this particular function is left cooling its heels while the database decides whether in fact it will or will not accept the stuff. Okay, so what we got here is we've dropped into the after trigger. Now, this particular file has a particular need for an after insert trigger because in the little database we were talking about, we had a balances file which kept some highly volatile financial information for the customer. And if you look at this balances file at the moment, there's only 1 record in it, not 2. Because we are now going to add that second record. We go down here. Again, we do the same thing. We set ourselves a parameter pointer, which at the moment is null. And after we step there, you will see it now has a value. We then look to see it's an insert. We set this offset to the new record back there to get a new pointer. And when we do that, we will have a new record. Now, this new record has got exactly the same values. You'll notice it is not duplicated. The record in the before trigger doesn't duplicate in the after trigger. And the reason for this is because they're actually not based on the same pointer. They are placed into a parameter list, so they actually are not, they may not necessarily be the same pointer. As a result, you're not getting the duplication of this record that you did in the IO server. Okay. We're going to go into the insert event. And in the insert event, it goes through and it sets the record status. The customer number is placed into the customer number for the balances file. It makes sure that the balances file fields are all 0. And then it goes and does an insert on the balance file. So I'm going to step into that one because I'm taking you through everything that is happening in this simple little process. So this is now designed. The request is to insert. This is an insert of the balances file. And so we go into the IO server for the balances. There it is. And it's very similar. I mean, there's a copy and paste. But here again, take note of this. It's not open, therefore I open the balances file. So I'm opening the balances file at this point in time. I am then setting the action and setting the balance file pointer exactly the same way as I did with the other IO server. In fact, exactly the same thing happens with this. These IO servers are very, very similar. Except here, I go into the put routine. I'm going to step into it. And the next statement is to write the record. Nothing fancy about this. I've already got the record. It's sitting there. Let's just have a look at the new record for the balances file. Where is it? Where is it? There it is there. The balances file, monitor that expression, and you will see it has a customer number of 2 and all the zeros. So that's the record that we are now going to do an insert into. Now, I never had a before trigger on the balances file. We didn't put one. So if I step into that right, it doesn't end up in another trigger because there isn't one on the balances file. But there could be. And then I would go into that trigger, and so on and so on. So this is where it ends in this particular case. I would then return with the indicator on to say the write was successful. And I return to the statement after the insert of the balances file. And I bypass the on error because there were no error conditions. Now I'm going to bring this back here. I'm going to, you can now see that in the balances file there are 2 records. So the second record has been added by the trigger to the balances file. We still have 2 records on the customer master file. Right, so I will step through that, end the insert event, and then of course I go to end monitor and I will return from this after trigger. Now watch what happens. This is where the sleight of hand occurs. I'm going to bring in and show you what the main screen still looks like. It's still got the system busy and the call. And I'm going to issue the return. This is the return from the after trigger, which passes control back to the database management system. So I'm going to step that, and I'm going to exit there. Now, what has happened is interesting. I am here in the IO server, and I have just issued a write. Instead of stepping down to that statement, which would return me to the test program, I've ended up in an on-error condition. The on-error condition is caused, and I will try and illustrate it by taking this, breaking this particular program, looking at the job log, and I am showing a referential constraint error, F1. The operation being performed on custom mask file failed. The constraint custmask R0 prevents record number 0 from being inserted or updated of dependent file, etc., etc. Because a matching key value was not found in member repmask file of the parent file repmasked in library AMWDB. So, what's happened is that the error, which is that referential constraint there, CPF502D, followed by CPF502D again, followed by RNX1022. Those are 3 error messages that are generated by the database management system because the constraint on the file was not valid. So we will hit this on error condition because that write had a failed constraint. So instead of returning happily, we've now got to an on error condition, and now we step in to the error handler, which does the percolate. Now, we've talked about the error handler. It takes the error messages that it found in this program's message queue and percolates them up 1 level to the caller. So if I do a step, you will see what actually happens. It ends up this, sorry, it was the put that failed, so it percolated the error up to the main line where the put was called. That put failed because of this IO server, so it has dropped straight through to the on error condition, and we percolate again through there and up to the test program right at the very beginning. But I missed the commit statement. Now, this is a key to the whole thing that you're going to see happening now. This commit statement was not executed because of the error that was encountered somewhere during that insert. We've ended up on the on error condition, and we are going to percolate once again. And this time, you will see where the message ends up. Percolate, and then I've got to drag this thing through here. Debug has ended, and there is your referential constraint error on file custmask F. It's actually come up on the command line because it's percolated up until it needs to be displayed. So that error message was generated by the operating system, and it was bubbled up to the command line. That's simple, straight percolation. If an error message had occurred in the trigger, exactly the same thing would have happened. So the test, the insert that we did, okay, the debug is terminated. We won't worry about that, because now what I'm going to do is I'm going to drag in this fellow again. This was the balances file. I'm going to show you the balances file as it is now. Record 2 has disappeared completely. I didn't do it. The system did, and the activation group did. Because the activation group has terminated, and you will also see that, in fact, the master file, the second record on the master file, is also gone. So both of those records have disappeared. And the reason for that is that this percolate of the customer test i.e. a resend of the escape message went out of this new activation group. Now, an activation group that is terminated by the transmission of an escape message does a rollback of all uncommitted updates, and it closes down all files, and it cleans up the whole activation group and then shuts the activation group down. So what we are faced with here is a situation as if this had never occurred in the first place. And in order to make that or prove that very clearly, I'm going to simply press the Enter key again and do this whole process all over again exactly as it stands at the moment. And it will, you can see, cross-system active. This time it's worked. And I'm back in my test. We get back to my test. Here I am, it's exactly the same test. I'm going into the I/O server for the customer master file. I'm stepping into it, and it's taking me to this statement here. Now, if you've been paying attention, which I hope you have been, you will have not seen a close anywhere. All these programs are linear main programs, which means that there's no RPG cycle in them. You have not seen an LR set on anywhere. So the question here is, if this customer master file is not open, I must open it again. And this proves what the activation group has actually done in the reclaim of resources. Because if I step again, it will go and open the file again, i.e., it was closed by the error in the activation group. The other thing that, now you can think, I'm going to just finish another sentence and you can think of all sorts of questions you would like to ask. But notice where the error of the referential constraint actually occurred. And it's important to understand this. The before trigger was done first, then the after trigger, and only then did the database management system pick up and report on the referential constraint error. So, it is possible in either the before or the after trigger, if it's appropriate to do so, and it follows what you want to achieve, you can identify a missing master record, and you can correct that condition in either the before or the after trigger before the database management system has a chance to check it. I.e., you might do a check, find it's not there, pop up a screen saying you have specified an invalid rep. Do you want to insert a new rep code? That you can do from a trigger. Maybe not a good idea, but you can do it, depending on the need of the application. So we know that all the files were closed, so I will go through and I'll open them all again. Now, where am I? I just need to be sure, because I'm going to try something that has just come to mind. And I'm going to step into the put. I'm going to go through the set lower limits, which of course is going to produce me customer number 2 again, because customer number 2 was deleted from the file. Then I'm going to fix the date. This is the customer master file. Then I'm going to step into the before trigger once again. CCOM's making it slow. I thought we'd get a few wobbles in this. Come on. It seems to have hung up, which of course is not surprising. This is Java, most of this RDI. Come on, man. Please. The put, oh, I've got the file locked. Sorry, that's me. I've got the file locked by this SQL statement. Once I get rid of that, it'll probably step through. Yep. Yep. No. Cheeky bugger. But it still hasn't released the lock. Obviously, there's a lock on it somewhere. Let me open that thing again and work object lock and see what I've got. So I'm just trying to work on the object lock to see. I'm sure it's a lock. Yeah. This program is holding a lock on its own. So that's not going to help me an awful lot. All right, I'm going to have to close this. Program has terminated. And let's work object lot. This is why I always like CAN demos, because then you can, nothing can go wrong, can go wrong, can go wrong. Okay, so we have no locks now, so that should be okay. So we should be able to go through and do the same thing again, just by hitting the Enter key, and we get back into the debug. I'm going down to here, run to that location, step into there, and run to that location, and step into the put routine and run to that location, which is the actual write statement. And I'm going to step into the write statement so I can get into the before trigger. Now I'm in the before trigger. let's just get down to the end of let's run to this condition here, run to that location. Why did you read my mind? If we look at this trigger at this particular point in time, and we look at the N record, which is the new record. Sorry for my abbreviated coding. But you will notice that rep code is still 44. It's an error. I can change the value of rep code inside the debug, inside the before trigger. So if I change it to 0022, there is a valid rep code. There's no error condition there. We return, and of course we will get into the after trigger. And if we look at the after trigger, and we look at the new record in the after trigger, if I can find it, there it is there. Monitor the expression, you will see that in the after trigger, the rep code is still 22. So it's carried it through. The change that I made manually in the before trigger is actually carried through into the after trigger. We can then leave the after trigger, return on, and because there has now been no error identified by the referential integrity, I haven't dropped past the commit statement. I've landed on the commit statement, and I will do a commit and a return to my customer test program. The test program has terminated. The debug has ended, and I will just show you that the command has actually successfully completed. Empty command line, no error messages. Let's have a look. STRSQL at the customer master file now has 2 records on it. And the balances file has 2 records on it. And all of that done with a magic wand that nobody saw happen. So I'm going to do it once more very quickly. I'm going to take that out of the way. And here I'm going to do a upddta update data. amwdb/rep mstf. I'm going to update the rep code. I'm going to put a rep code 44. Well, let's just do an F10. I'm going to put a rep code 44 into here, and I'm going to call this Marinus VS, and his cell number is 555-678-910, and his commission is 0.03%. No, that doesn't work. Commission percentage 0. No, why doesn't the point work? Oh, doesn't matter. 0.03 is probably just as good. I'm getting insulting remarks. But we'll give you 3%, why not? So what I've done now is I've added rep code 44 to the file. And I will now, from here, with the debug, I'm going to call custest. And of course, it will break in the debug again. But I'm not going to debug. It is 44. It's now a valid rep code because I've added it to the master file. As a result, I'm just going to hit this green arrow which says proceed to the end. And I will return the screen, and there you are. It's executed without an error. If we use the debugs, the sequels, the master file now has 3 records on it, and the balances file has 3 records on it. So, as you can see, an awful lot happened under the covers. I'm just going to terminate this debug. Go back here. I'm going to drop the service entry point because we don't need it any longer. And just have a look at this code. That statement caused an awful lot of activity to occur under the covers to give you a proper resolution to the business rules of the business requirements around a customer master file. Obviously, what we've got here is a very simplistic solution. But I don't think it's going to take too much imagination to see how you can actually scale this up to do quite a lot of stuff. Now, I just want to show you one more little thing. In terms of speed, I've taken the debug out. I'm just going to run this again. Except I can't really run it again because, well, I can. Except it's not going to give me a duplicate. It'll just give me another one. So that's fine. I press the Enter key now. It's done. All of that calling in the background, right the way down, you can see the programs involved. Marina says applause is acceptable right now. It went through all those programs, right down to the balances program, and it could have gone through a before and after trigger on the balances file, and it could have done a lot of other stuff. They are highly optimized. They are very quick. Oh, you want to see the 2 files? Sorry, I neglected. I was going to. Here we are. This one, the master file has now got 4 records in it, and the balances file has now got matching 4 records in it. You should actually do this to everyone so they can actually see what flack I'm getting from Marinus at the moment. All right. So this is a good point in which to ask me any questions that you may have, please, so that I can answer them. Shock and horror, or awe and wonder, I'm not sure. The thing that I have to stress, and I would like you, please, if you don't do anything else between now and Thursday, or even between now and the weekend. What is today? It's Tuesday. Watch this recording again. follow it through and try and understand. Flowchart of last week. Okay, Marinus has suggested I bring up a flowchart of last week. Just trying to see whether... Are you talking about the activation groups, Marinus? Yeah, okay. Let's just see whether we can bring up activation groups onto the screen. Right. Okay, this was the detail with the linear main and the cycle main procedure. Programs, modules, commands. Here we are. In fact, this particular test, and I stress, I do these little test programs for virtually every single file that I create in a database. Building databases, you need to be sure that all the ducks are in a row. So I create a little test program, and it's usually in this sort of new activation group, because then I don't have to worry about closing files, cleaning up after me. It's all done for me. And if there's an error, which there usually are one or two to begin with, I don't have to worry about half-updated databases or anything like that. So I can do tests on files or multiple sets of files using these programs very easily. And as you can see, you can step through and look at each process. So basically what we're looking at is this type of thing. There's the program, and in this case it calls the I/O server to do an insert, which opens the file, and so on and so forth. These are activation group callers. The triggers are activation group callers. So I think that one, yeah, we can keep that one. So that's essentially the flow. If you feel, I've been asked by Marinus to try and put some sort of flow diagram together, which I'll try and do for next week, to try and illustrate this particular example in a simple graphical connected, Thursday. That's 2 days from now. Just so that we can have something similar to what you're seeing in front of you at the moment, but just a simple flow to show you where we go to from one to the other. In fact, I'm almost inclined to think that there is one that I can use. This one. This particular diagram, which encompasses basically the whole database, very much the type of thing that we've seen through the debug process. There's an insert into the customer master file, and the before trigger makes sure that the record is 100% correct as far as it's prepared to go. It doesn't look at the referential integrity stuff, because that's not relevant to a trigger. So the before trigger that goes through its thing. Then the after trigger will be called, and it goes through the IO server for the balances file and puts a record into the balances file, and then returns control to the one thing I don't have here, which is the IO server. But in the process of returning control to the customer master file test program, the database management system checks that relationship there and says, it doesn't work. You haven't got a rep on the rep master file. Therefore, I will throw it out. So what I'll do next for Thursday is I'll take this little diagram and I'll just shuffle it around a bit to graphically illustrate what we've gone through at this particular point in time. Is that reasonably happy for people? You will have it then on the recording, and you can, I don't know, can you do a frame grab out of the recordings that we have on the Dropbox? I think you can. Or you can frame grab and put together a combination of pictures. Are there any questions? Really, I would love to have some questions, because I'm worried that either you've put you all to sleep or chased you away or what. Okay, sorry, is that stunned silence? Okay, I'm going to ask you a question, because did this answer the question you asked me before the session? Does it put it into better perspective?
No. I think my question was more of an issue with the start commitment control. The program I had that in it's not the modernized where you have the IO server. I was actually starting commitment control in a CL with a star job instead of star activation group.
Okay.
The activation group in my program is a star new, but it's not releasing the lock on my records when I do the interactive, which makes me think I need to change the commitment control to a star activation group.
You probably would need to do it within an activation group, because if you're not, you might be doing a commit, but not at the right place in the whole process. I suspect that's what it is.
If you have your start commitment control in the CL that is running under a different activation group, star default, where the program is a star activation group, a star new, will it still work? Or do I need to move? I need to move the commitment.
That's where the problem is. You either have to start your activation group when you compile your seal. You need to compile your seal with activation group star new. Seal programs also. Let me just get. Let me just find the screen here. Create. Is it bound seal? BNDCLLE, something like that. Never use it. Come on, somebody tell me what's the compile? Create bound CL. Oh, there we are. Create bound CL. Here you've got when you create your CL. I don't use CL at all, because I do it all in RPG, because I mean it's a single skill set. So I haven't got a great. But here you can say default activation group, and you can put your new activation group. So it's the CL program that will start the activation group. Then in your CL program, you can start commitment control, and then you will have it all in the same activation group. Okay. Does that give you the answer? Okay. I assume that actually answers the question, okay?
Yes.
Okay, good. Yeah, I tend not to use CL anymore, because it really is just much easier to use RPG. Just as an example, let me just show you, because this is one of those things that one does when you start modernizing your code is, if you look at this little test utility that I put together, you'll notice there's a call here to a thing called command. Now, this I created many, many years ago. It's a wrapper for QCommand exec. That's all it is. It's a command procedure, has a 4096 byte variable size parameter, and you simply just issue the command like that within quotes. You can also concatenate that command if you like. It calculates the length and executes the command. And that is what I use to execute CL commands inside RPG. It's very, very simple and very easy to put together. Anybody wants it, send me an email, and I'll send it to you because it's very simple. The only thing it doesn't do, which, okay, I'll open source it. Marina says I'll open source it. I'll stick it into the RPG ILE open source component. The only thing it won't do, of course, is run any command that is going to return you a value. Most of those commands, the retrieve CL commands, most of those are supported by APIs anyway. As a result, I rather wrap an API and use the retrieve command in a procedure, in an API wrapped by a procedure out of a service program. So that is why I tend not to use CL anymore, because I just wrap up RPG to make it work for me. But that's not a mandatory requirement. It just makes everything a lot simpler. Okay. Whew. I'm glad we got through that. I hope it was meaningful for you and putting it together. I will do a little diagram. Oh, sorry, Kay, I missed your answer on the chat box. I'll put a little diagram just to see if I can get it in a very simple form. My recommendation here, when you want to get a handle on this, is actually to take the code that is actually in the open source environment already. I think it is. Compile it and actually do the exercise that I've just done for yourself. Yes, here we are. All of this is, there's some triggers there. There's example stuff here. You'll probably get most of it out of the open source. Customer master file before trigger, customer master file after trigger, the balance file, the master file. So it will probably be there. If it isn't, I will make it available. And it's like I've often said, that it's all very well to listen to somebody talk for hours on end, like you've been listening to me. Thank you very much. But the actual doing, the actual sitting down, coding, compiling, cleaning out errors, and then doing this debug step by step will help you embed this in your mind. And you can use a simple example like I've got here until you're happy, you understand its permutations and combinations. And then if you feel like it, you can extend it so that it drills down 7 different levels of files, each with a before and after trigger, if you've got that much time. But you need to do it as a practical exercise. Just hearing about it and then deciding one day when you are faced with a task to try and implement it can be very frustrating. because until you're comfortable with the whole way it connects together, it's very difficult to take a request and design a solution using this methodology without knowing really how this methodology works. So exercises are important. Now, a couple of sessions ago, I said, please play this piece to your management. This is one of the things you need to be given time to do. You need to be given time to experiment with little things like this to understand how they hook together. The same thing, Kay, with that, what you asked about that activation group. You need to make sure you understand where the boundaries are and how they sit together and where and how things behave. Because, and this is the problem, this modern stuff is great fun. It's fast, it's economical, you write so few lines of code to do so much, but it's in little pieces, and it's not as easy to join the dots as it is when you've got one huge monolithic program. So one needs to become comfortable and familiar with the whole process. Then you will have a database that nobody can mess with. And you can do this a little bit at a time. Now, in the next 15 minutes, which is what we have, I want to just introduce you to another type of trigger. I don't know whether I've covered it before. I don't think so. Because it was designed, I designed it quite recently at the request of a customer, because there was this problem that when you have a legacy system, I have written an ISO, okay, Ed, let's see, I've written an ISO after listening to a session, then gone back and re-listened to a session. Yeah, thank you, Ed. That's exactly the sort of thing that needs doing. Write it, see how it works, re-listen, go back. This is why we're making these recordings, and this is why these recordings are so important, because they are ways of going back and having a look. Now, I might waffle a lot, but you can always cut those pieces out and only hang on to the stuff that's important. And thanks, Ed. That's exactly what I was getting at. I'm just looking for the particular trigger. Okay. Right, let's trash this. I will probably follow this up in a little more detail Thursday, because I don't think I've got enough time to go into it in depth at the moment, but I will give you the concept. A legacy system has programs that read, write, insert, and update records to a file. And the problem with that legacy system is it wasn't written to handle trigger-generated errors, or even referential constraint-generated errors for that matter. So if it's actually handling any type of I/O errors at all, which is quite rare for legacy programs, because in the old days, and I'm just as guilty as anybody else of doing it, we used to ignore any error that we thought was never going to happen and only pay attention to the errors that we knew were going to happen, instead of writing code that made the errors we knew were going to happen not happen and concentrate on the ones we didn't expect. But that's another story altogether. So we have a problem in taking a trigger, as I have described them to you, or constraints as we've discussed them, and just attaching them to a legacy file because you're going to break your application. And this was brought to me as a problem. Oh, okay. That's a good idea. Marinus always comes up with good ideas, but he then makes me read them out to you instead of typing them to everybody. I have on the post, where is it? Here, on the forum. On the blog, actually. In the blog, there is event triggers. There's the modern. Where's it gone? Okay. Sorry, under the event triggers topic, there's two things. There's pulling the DB2 trigger, a solution example. Initially, there's a blog about how you put triggers onto legacy files without shooting yourself in the foot, i.e. without breaking your system. And then I have provided a solution example of exactly what code needs to be put in place to allow you to log the errors rather than report them back to the user or to the user program. So these two are worth going through, having a look at, downloading and reading, because these will give you a way of adding triggers to a file, a legacy file, without breaking your application. That is the main issue. No, I was just had something. Oh yes, I was here. The essence of it is I have a file A. I made up a file A. If I can find it. Here it is here. I made up a funny file called file A, and I created a trigger. Now I'm going to run through this, but I would like you, if it's possible for you, to read those two blog postings as well to support this. This is a trigger for a file called file A, but it's designed to determine whether the program that was used to call this event is a legacy program or not. Now, there's a utility there as well. It's in the open source. It's check legacy to see whether the program that made the call is a legacy program or not. Now, that's done simply by checking to see which library the program came from. So legacy programs would be in a legacy library. Modified and enhanced and updated programs would be in another library. As a result, this trigger can differentiate between the two and can respond appropriately. Basically, the trigger, the first thing it does is it goes to check legacy and sees whether the call came from a legacy program or not. Simple as that. A legacy indicator is set on to say, yes, it was legacy, no, it wasn't. Then let's have a look at what happens. If there was an error and the program was not a legacy program, then we percolate the diagnostics and we send a conventional escape message. Okay, we do nothing else. If it was an error and it was a legacy program, we don't do anything at all, i.e., we return to the program without any indication of an error having occurred. And that is the important thing, because we don't want to break the program. It's not used to getting escape messages back to saying, this should be a Y or an N, not an X. So if it's an error and it's not legacy, we deal with it properly in the normal, correct manner. But if it's an error and it is a legacy, we just return control. That's the next step. Return control as if there were no errors and your program can continue. But, and this is the trick, when you are in the validation routines, here, for example, this is validating a field called file type, which has to be one of those. Okay, so if the check shows a non-zero value, it means that there's a value in file type that's not in that string. We turn the error on. So the error indicator is turned on. However, if it's a legacy program, we put the message into the error message and we write a log file record. I'll just open the log file. This is using a log file IO server, and the log file looks like that. It has a file name, an event indicator, a program name, a log date timestamp. It has an error message, which is the error message that identifies what error has occurred. It has error text, which you might use for substitution. It has a before and an after image of the record that caused the error. And that is the log record that is written by that IO server there. So what happens with this trigger? When it's called by a program event driven by a legacy system, is that it finds an error based on the business rules built into the trigger. But instead of reporting it as an error back to the calling program, it logs it into a log file. And this log file, by the way, is common. You can use the same log file for multiple triggers. So a whole handful of triggers can pour their errors, their discovered errors, into the log file, because you can separate it by file name, event, and program name. And what you can do then is you can work through the log file and see which legacy programs are trying to or adding data to the database that is against the business rules. And you can identify what the problems are with the legacy programs. Or you might identify that you have missing business rules, or business rules that are not correct because you've picked them up from one place in your system, but somewhere else in your system that business rule is failing. So you can use this to identify and log what is not right. It also, if you happen to start doing things like, if one of your legacy systems is putting character data into a numeric field, decimal data errors, corrupted data coming from somewhere, misaligned data that is being placed into a character field, all of these things will fail certain validation checks and will then be dumped into the log file for attention, either program at a time or file at a time or whatever you want. And once a particular legacy application or legacy program or whatever it is stops generating errors into the log file, you can go into that program, you can modify it so that it now will cater for errors returned in a modern way, and then you move it into the non-legacy library, and then it will begin to operate as a modern program with trigger-driven errors, and you don't actually have to change anything in the trigger. And that can go on. You can run triggers like that continuously for a very long period of time until you're absolutely certain that everything is cleaned up before you fix it and move it into a modern paradigm. So this was specifically designed. Let me just see if I can pick it up here. It is here. There's the 2, but in the open source, I think, yes, DB2 triggers this here. In fact, you can get the 2 blogs here as well. Without shooting yourself in the foot in the solution example, those are the are the documentation, and then from sample file A all the way down here is all the code that you need to generate. In fact, I've even given you 2 triggers, one fully free and one part free trigger, just so that if you're into that sort of thing, you can use them. So this is an example of how you can attach triggers to legacy files and legacy applications with no risk to breaking your system. What it will do is to collect possible anomalies for attention at a later date. So it's very worthwhile looking at this as a possible first step to start adding triggers to your database and collecting anomalies for attention. And wow, that's perfect timing, even if I say so myself. I hope this has been valuable. If there are any questions about any of the stuff that we've spoken, please send me emails. I would most appreciate receiving any feedback at all. And if you try some of this stuff, it doesn't work, please let me know. Send me job logs, and I can... Okay. Thank you, Kay. So hopefully it stitched a lot together. And maybe try it for yourself. Take this recording, write the code that you've seen, try it for yourself, and get comfortable with it, because this is powerful, very powerful. And once you get into it, you won't want to go back to the old ways, I promise you. There's so little code you write here for so much benefit. You will have plenty of time to get on with some good stuff instead of chasing bugs around the world. Thank you, ladies and gentlemen. I really do appreciate your attention. We will meet again on Thursday, all being well. Thanks a lot.